Okay, so am I audible to all of you?
Yes, sir.
Yes, sir.
Okay, so today we are going to discuss some two important problems. Okay, based on myopia and hypermetropia. Okay, so before that, we have to just rewind, like just revise the topic that we studied under the light. Okay, so under the light we studied lenses, right? Convex lens and concave lens, right? So how the image forms, everything we study, right? So for myopia, for the correction of myopia, what type of lens we have to use?
Concave.
Concave.
Concave. Okay. And for hypermetropia, what type of lens we have to use?
Convex.
Convex, right? So how we can use this and what exactly these lenses are doing to correct this myopia, okay, or the hypermetropia. Okay, so that we will understand by doing these two problems. Okay, yeah. Okay, so in the case of a concave lens, what type of image you will get under different position? If I am moving the object from infinity to towards the lens, towards the concave lens. Okay, so what type of how the image? What is the nature of the image? Any idea, Abhi?
The question was no, sir.
For concave lens, we study, right? The image formation, last chapter, right? Yes or no?
Yes, sir.
So, how will be the nature of the images for concave mirror, concave lens? When I am moving the object from infinity to towards the focus. This,
Yes, sir.
hmm, the
Sir,
case of a
virtual and erect.
concave mirror, concave lens,
Virtual and erect.
virtual and erect, right? Always, right? Virtual and erect and diminished. In the case of a concave lens. Okay. And what about convex lens? We can get only real image or only virtual image or both.
Both.
Both, right? But at one position we will get a virtual image. Where it is
Between F1 and optic center.
F1 and between focus and pole. If you keep the object between focus and the pole of a convex lens, we will get a erect virtual image on the same side of the lens, right? Okay. Now just write down this problem. This is a numerical based on myopia. Okay. So what is myopia?
So
What
short
is
sight.
myopia?
Short sight.
What is myopia?
Short sight.
Louder, louder.
Sir. Short sight.
Short sight. That means
A person can see nearby objects clearly and
we can see
distinct
nearby
object.
object, but we cannot see far objects,
Distinct.
right? So after a certain distance, we cannot see the objects. So that is myopia, right? Okay. Here, write down this problem. Very, very complicated problem. Two problems. Okay. The far point of a myopic person is 80 centimeter in front of the eye. Okay, write down. The far point of a myopic person is 80 centimeter in front of the eye. Full stop. What is the nature and power of lens required to correct the problem? What is the nature and power of lens required to correct the problem? So let me ask, what is the near point and what is the far point of a normal eye? Normal eye means without any defect. What is the near point, Abhi?
So 25 centimeter.
25 centimeter is the near point, right? And what is the far point?
Infinity.
Infinity. That means long distance. That may be 3 meter, 5 meter, 6 meter away. Long distance from. So that is the normal line. But when they, here, what is the question? The far point of a myopic person is 80 centimeter in front of the eye. What it means? The far point. The far point of a myopic person is 80 centimeter in front of the eye. What it means?
Sir, till 80 centimeter he can see clearly.
Yeah, till 80 centimeter we can see. See, this is the human eye. Okay, the normal eye near point is 25 centimeter and far point is infinity. Okay, I just pretend. Now here it is saying that the myopic person, the far point is 80 centimeter. That means after this 80 centimeter you cannot see anything, right? You can see the red color, right? Red line. After 80 centimeter I marked it is a red color. So this person cannot see anything after 80 centimeter. That's why we call it as a myopic, right? He can see the nearby object within 25, means after 25 centimeter, 25 to 80 centimeter he can see nearby object, right? Clearly. But after 80 centimeter he cannot see. So that's why it is myopic. Sometimes in question this will not give. You will able to understand how you will how you will understand that if it is saying that this person not able to see anything after a particular distance, for example after 80 centimeter or after 1 meter, then what it is he cannot see long distance objects, he can see only nearby objects. That means myopia. Okay, that is the way you have to understand. Suppose the question is like this person is not able to see anything between this or anything within this 80 centimeter, then what is the fault? He cannot see anything near. It is, but he can see far. So that is hypermetropia. Okay. If beyond, he cannot see anything beyond certain distance, that is myopia. So here it is already given. It is 80 centimeter. So uh, within this 80 centimeter he can see, but after 80 centimeter he cannot see. That's why the far point of a myopic person is 80 centimeter. That is the meaning. Clear? Clear? The
Yes, sir.
far point of a myopic person is 80 centimeter, means after 80 centimeter he cannot see anything. Okay, so this is the defect, right? And this defect we will call it as a myopia, right? So we have to correct this, right? We have to correct this. We will keep particular lens here and we will correct this. But what exactly, how we will correct? Just think how we can correct this. This person can see anything between 25 to 80 centimeter. This green color is between 25 to 80 centimeter. He can see anything, right? After 80 centimeter only he is having problem, right? So if I am able to bring this object which is at infinity between this I can see it. So no. Suppose I am bringing now for this myopic person, he cannot see anything at infinity. That means after 80 centimeter, he cannot see anything, right? Suppose I am keeping an instrument here. We don't know what type of instrument I am keeping here. And I am bringing this object. I am bringing this object between this using this instrument that I am keeping here. Then I can see it. Yes or no? If I am bringing between 80 and 25 centimeter, there is no problem, right? I can see it from using my eye, right? So this concave lens is doing that. Okay, how? That is the next question. How? How it will bring? So if an object is at infinity, if an object is at infinity or any point between 80 and infinity, okay, so that is object. So this concave lens bring that object as an image of this lens. It can produce an image, right? Yes or no? Can produce an image or not? This concave lens. So object is at what position? At infinity. Okay, object is at infinity. This infinity. If I am keeping a lens here, concave lens here, it can produce an image. It can produce an image. Concave lens always produce image on the same side. So no.
Yes,
So
sir.
no. Concave lens always produce image on the same side. Okay. Now I am taking here. What is the object distance here? Minus infinity u with respect to this lens. Okay, with respect to this concave lens, the object distance is infinity. What is the image distance? Where we are going to produce the image? എവിടെ produce ചെയ്യണം? Between 80 and 25 centimeter, right? അല്ലേ? 80 സെന്റിമീറ്ററിന് ഇങ്ങോട്ടേക്ക് കാണാൻ പറ്റുന്നില്ല. Cannot see. So I have to produce the image of this object between here. So I am taking that image distance b is equal to minus 80. Why I am taking minus? Why I am taking minus?
See,
Why?
sir.
Louder.
Sign convention.
Sign convention. That means the measurement is left side of this lens. Right? Now, what I have to find out? What is the power of the lens? Nature and power of the lens. So, if I want to find out the power of lens, what is the equation?
1 by f.
And
By
F.
Find out. So, I have to find out f, right? So, which formula I have to use? U, V and F. Which formula?
Lens formula.
Lens formula. That is 1 by V minus 1 by U is equal to 1 by F. Substitute and find out. 1 by minus infinity minus 1 by 1 by minus 80 minus 1 by infinity is equal to 1 by F. Substitute and find out. 1 by infinity is what? Abhi? 1 by infinity. 1 by infinity is what?
so infinity.
Louder.
Infinity.
1 by infinity is not infinity. 1 by infinity is what, Avani? Devananda, 1 by infinity.
So the object distance.
1 by infinity is equal to 0. Okay. 1 by infinity. 1 divided by a big number. Infinity means a very big number, right? So 1 by infinity is 0. Okay. So this equation will become 1 by minus 80, which is equal to 1 by f. F is equal to minus 80, correct? F is equal to minus 80. So power is equal to minus 80 centimeter, right? Minus 80 centimeter. F. So Power is equal to 1 by F is equal to 1 by minus 80. Find out. What is the answer? 1 by 80. Find out. 1 by minus 80. So power will be negative, right? Focal length also we got minus 80 centimeter, which is equal to 0.8 meter. We have to convert into meter because diopter for getting the power, always the focal length should be in meter, because one diopter is equal to 1 diopter is the power of the lens which is having focal length 1 meter. So that's why any measurement, especially the focal length, we have to convert into meter. So here a minus 80 centimeter is equal to 0.8 meter. Find out minus 0.8 meter. This negative sign shows it is a concave lens.
So 1.2D.
1.125
2D.
D minus, okay, minus 1.25 D, that is the power. Minus shows it is a concave, that is short side. Focal length is minus 80 centimeter and power is equal to minus 1.25 diopter D. 1 by infinity, what is the value? Abhi?
0.
0. Okay. Clear to all of you?
Yes, sir.
Yes, sir.
Okay. Next problem. Write down this problem. Try to do this. Same way, but the problem is different. A person is unable to see objects distinctly placed within 50 centimeter from his eyes. This point. Write down and read the problem clearly and understand what is the defect. A person is unable to see objects distinctly placed within 50 centimeter from his eyes. Name the object. Sorry. First question. Name the defect. Name the type of lens need to use to correct this defect. Calculate the power of the lens. Name the defect. Name the type of lens need to use to correct this defect and calculate the power of the lens. Write down, read it. These are the two types of problems, complicated problems. Abhi, tell me. Switch on the video and tell me. So what type of problem this person is facing? Is myopia, hypermetropia or presbyopia?
Sir, myopia.
Why?
Sir, because the person is unable to see distinct objects. So,
How it is saying a distance object? Distinctly placed. A person is unable to see object distinctly placed within 50 centimeter. within 50 centimeter, not beyond 50 centimeter. Beyond 50 centimeter means 50 സെന്റിമീറ്ററിന് അപ്പുറത്തേക്ക് ഒന്നും കാണാൻ പറ്റില്ല. 50 സെന്റിമീറ്റർ ഉള്ളിൽ കാണാൻ പറ്റും. That is short sight. That is myopia. Here what it is? He cannot see, he is unable to see object distinctly placed within 50 centimeter. That means from 50 centimeter to 0, I mean up to my eye, he cannot see anything. That is what after 50 centimeter he can see. That is understood. Within 50 centimeter, short object he cannot see. Long object, long distance object he can see. What is this? Hypermetropia. That is very, very important. How you are identifying the problem. See here, 25 centimeter infinity is the normal, near point and far point, right? Now 50 centimeter, see red line. So what it means? Unable to see object distinctly placed within 50 centimeters. So 50 centimeter to this. This is within 50 centimeter, right? Correct. Now if it is away 50 centimeter or beyond 50 centimeter on the red line, എവിടെ വരും? എവിടെ വരും? ഇവിടുന്ന് ഇൻഫിനിറ്റിയിലേക്ക് വരും അല്ലേ? അല്ലേ? 50 centimeter. അപ്പോൾ മയോപ്പിക്. So here it is hypermetropy. He cannot see anything near the eye, but he can see away. 50 centimeter away he can see anything, but within 50 centimeter he cannot see anything. So name the defect. What is the defect, Gopika? What is the defect?
So hypermetropia.
Hypermetropia. So we have to correct it, right? So for correcting hypermetropia, we have to keep what type of lens, Avani?
Sir, convex lens.
Convex lens. Okay, I am keeping a convex lens here. I am keeping a convex lens here. So what we need to do to correct? If I am keeping the convex lens here, what this lens has to do? Think in the same way.
Sir, to form the image between 50 and
Between
50 and
50
infinity.
and
between 50 and infinity, right? So this convex lens need to produce those image and produce the image of the object which are kept at 50 centimeter, right? So 50 centimeter or 25 centimeter, anywhere. So 25 centimeter correct up to 25 centimeter, because starting point is 25 centimeter, right? 25 centimeter model 50 centimeter, he cannot see anything. But 25 സെന്റിമീറ്ററിലുള്ളത് കാണാൻ പറ്റണം അതല്ല ശരിക്കും നമുക്ക് ആക്ച്വൽ കണ്ടീഷൻ അല്ലെ. നമുക്ക് ഇഷ്യൂസ് ഇല്ലാതെ നമുക്ക് നിയർ ഒബ്ജക്ട്സിനെ കാണുക എന്ന് വെച്ചാൽ 25 സെന്റിമീറ്ററിലുള്ള ഒബ്ജക്ട്സിനെങ്കിലും നമുക്ക് കാണാൻ പറ്റണം. സോ ഒബ്ജക്ട് വിച്ച് ആർ കെപ്റ്റ് അറ്റ് 25 സെന്റിമീറ്റർ, അതിന്റെ ഇമേജ് വി ഹാവ് ടു പ്രൊഡ്യൂസ് അറ്റ്ലീസ്റ്റ് അറ്റ് 50 സെന്റിമീറ്റർ. സോ ഹിയർ ഒബ്ജക്ട് ഡിസ്റ്റൻസ് എത്രയായിരിക്കും? u എത്രയായിരിക്കും? 25 centimeter minus 25 centimeter. ഓക്കെ, എവിടെയാണ് ഇമേജ് പ്രൊഡ്യൂസ് ചെയ്യേണ്ടത്? 50 സെന്റിമീറ്റർ. കാരണം 50 സെന്റിമീറ്റർ മുതൽ അപ്പുറത്തേക്ക് നമുക്ക് എവിടെ വേണമെങ്കിലും കാണാൻ പറ്റും. സോ v is equal to minus 50 centimeter. Okay, minus 50 centimeter. സിമ്പിൾ. ഹൈപ്പർമെട്രോപ്പിയ ആദ്യം ഐഡന്റിഫൈ ചെയ്യേണ്ടത് ഹൈപ്പർമെട്രോപ്പിയ ആണെങ്കിൽ നിയർ ബൈ ഒബ്ജക്റ്റിനെ നമുക്ക് കാണാൻ പറ്റില്ല. സോ ആ നിയർ ബൈ ഒബ്ജക്ട്, ആ 25 സെന്റിമീറ്ററിലുള്ള ഒബ്ജക്റ്റിനെ നമുക്ക് കാണാൻ പറ്റില്ല. ആ 25 സെന്റിമീറ്ററിലുള്ള ഒബ്ജക്ട് നമുക്ക് അപ്പോൾ വി ഹാവ് ടു ബ്രിങ് ടു ദിസ് പാത്ത്. സോ അറ്റ്ലീസ്റ്റ് 50 സെന്റിമീറ്ററിലേക്ക് കൊണ്ടുവന്നു കഴിഞ്ഞാൽ നമുക്ക് വി ക്യാൻ സീ ദാറ്റ് ഒബ്ജക്ട്. സോ ഒബ്ജക്ട് ഡിസ്റ്റൻസ് ഇസ് 25 സെന്റിമീറ്റർ. ദാറ്റ് ഇമേജ് ഷുഡ് ഫോം അറ്റ് 50 centimeter. Exactly. I have to break this. So object distance is u is minus 25 and v is this minus 50. Now we can find out, right? 1 by b minus 1 by u is equal to 1 by f. Find out f കണ്ടുപിടിക്കുക, then find out the power of the lens. Finding the u and v, that is more important. First you have to find out what is the defect, then what is u, what is v. That if you found, it's very simple. Actually, in the case of myopia, which point is shifting, near point or far point?
Far point.
Far point, right? Far point means long distance infinity ലാണ് normally നമുക്ക് കാണാൻ പറ്റുക അല്ലെ, normal ആയില്ല. But that will reduce infinity എന്നുള്ളത് ചിലപ്പോൾ നേരത്തെ previous questions എവിടെയായിരുന്നു 80 centimeter അല്ലെ, 80 centimeter അപ്പുറത്തേക്ക് you cannot see anything. So far point is shifted in the case of myopia. In the case of hypermetropia, we cannot see anything near, right? We cannot see anything here near, we can see far. That is hypermetropia, long side. So here, why we cannot see anything near? Because the near point is shifted. So here 25 centimeter എന്നുള്ളത് 50 centimeter like shift ആയി. Okay. Got it? Aaron? ഇല്ല. Devananda?
No.
Yes, sir.
Got it? What is the answer?
Sir, the focal length is 50 centimeter.
And power is 2
Power
diopter,
is,
right?
yes, sir.
So how we are getting? So 1 by b minus 1 by u is equal to 1 by f. Implies 1 by minus 50 minus 1 by minus 25 equal to 1 by f, equal to 1 by 25 minus 1 by 50 equal to 1 by f. Implies 25 and 50. 50 minus 25 is equal to 1 by f. So 50 minus 25 is 25. 25 divided by 25 into 5 is equal to 50 centimeter, which is equal to 0.5 meter. അല്ലേ കിട്ടിയ 0.5 meter അല്ലേ കിട്ടിയ?
Yes, sir.
Yeah, f is equal to 0.5 meter. ആയിരുന്നു കിട്ടിയോ ഇപ്പോ? Okay. So focal length is 0.5 meter. So diopter is 1 by 0.5. That means 2 diopter, right? Why we are converting this 50 centimeter to meter, Aaron or Matthew? Why we are converting this 50 centimeter to 0.5 meter? Matthew? Matthew? Matthew, are you there?
Yes, sir.
Why we are converting? ഉറങ്ങുകയാണോ? Why we are converting 50 centimeter to 0.5 meter? എന്തിനാ കൺവേർട്ട് ചെയ്യുന്നത്?
To get the image. To get the image.
To get the image of. Power കണ്ടുപിടിക്കണം. Power കണ്ടുപിടിക്കാൻ വേണ്ടിയിട്ട് നമുക്ക് 1 by f അല്ലേ. പക്ഷെ നമുക്ക് diopterലല്ലേ എഴുതണ്ടേ. We have to write in diopter, right? So diopterൽ എന്ന് വെച്ചാൽ എന്താ? What is 1 diopter? What is that 1 diopter? Days.
Sir,
What
1
is 1
meter.
diopter?
1 meter.
That means the power of a lens which is having focal length is equal to 1 meter ആണ് അല്ലേ. അവിടെ 1 meter ആണ് അതിന്റെ definition. The definition of power 1 diopter is related to 1 meter. That focal length 1 meter ആയിട്ടുള്ള ഒരു ലെൻസിന്റെ പവർ ആണ് 1 diopter. So നമുക്ക് if you want to write the power in diopter, first we have to convert the focal length into meter. So 50 centimeter is equal to 0.5. അതുകൊണ്ടാണ് 0.5 meter എന്ന് എടുത്തേക്കണം. അല്ലെങ്കിൽ 1 by 50 centimeter എന്ന് എടുത്തു കഴിഞ്ഞാൽ ആൻസർ തെറ്റിപ്പോ. 1 by 50 centimeter ചെയ്തിട്ട് 2 diopter means അതൊക്കെ ഒരു വാല്യൂ കിട്ടും അല്ലെ 1 by 50. ആ വാല്യൂ നമ്മൾ അത്ര diopter എന്ന് എഴുതി കഴിഞ്ഞാൽ that will be wrong. You have to convert into meter, then divide 1 by f. Okay, 1 by 0.5 ആണ് ചെയ്യുന്നത്. 1 by 50 ചെയ്ത് കഴിഞ്ഞാൽ ആൻസർ wrong ആവും. Okay, so that's why we are converting into meter. മനസ്സിലാക്കണോ? അതാണ് 1 diopter എന്താന്ന് അറിഞ്ഞു കഴിഞ്ഞു കഴിഞ്ഞാൽ then it is clear. Okay, അതിനാണ് നമ്മൾ സെന്റിമീറ്ററിനെ മീറ്ററിലേക്ക് കൺവേർട്ട്